Yes, hi everyone. Good evening. I think I'm audible to all of you. Let me know in the chat. So, guys, am I audible to all of you? Okay, fine. So, we can start our session. So, first of all, just give me a minute. Yes, hi Pyle, hi Krishna, hi everyone. Hmm. Yeah, hello. Good evening. Good evening to all of you. So, guys, welcome to the day two of our computer vision with real-time development course. And yesterday I was discussing about the introduction part of computer vision, and I already discussed about the Uran and its services and all, right? What is the day one video? It is available in the dashboard, even it is also available in the YouTube channel. Okay, check out my YouTube channel or Uran YouTube channel. So everybody will get that. And see, if you want to get all the lectures, so what you can do, let me share my screen. Mm, yeah, so I think my screen is visible, guys. Can you see my screen? So see, guys, this is the dashboard. If you go to the Uran portal, so here you will see this course, computer vision with real-time development. Okay, and this is not a free course, guys. This is a paid course. It's around $24. Okay, but if you don't want to take individual course, that time what you can do, you can take the Uran Plus subscription. Okay, see, just a minute. I think I shared my wrong screen. Yeah, so I think now screen is visible. Hmm. So guys, you can see if you go to the Uran platform, so here you will see this course called computer vision with real-time development. Okay, this one. And this is not actually free one. This is a paid course actually. So it's around $24. Okay, let me share you the link in the chat. So this is the link. Okay, so if you are interested, you can enroll for the course. So a few of the session would be live on our YouTube channel. Okay, but going forward we are not going to contact the live on our YouTube channel. Okay, but if you don't want to take the individual course, so what I will suggest, guys, try to take the Uran Plus subscription. Okay, so if you're taking Uran Plus subscription, so what will happen, you can access all the courses, okay, from the Uran side, whether it's a recorded, whether it's a live, okay, whether any kinds of upcoming courses, everything you can access, okay, with a single subscription. So you don't need to take individual courses that time, and 1 year you can access everything. Okay, so I will suggest go with the Uran Plus subscription so that you can access all of the courses from the Uran side. So let me also share you the link in the chat. This is the link I have shared. Fine. Okay, and where you will get the like recording and everything. So see, this is the dashboard. So computer vision with real-time development. Okay, so this is the dashboard. You can see course has started from 8 January 2025. Okay, and the class timing would be Wednesday and Thursday 7 p.m. IST to 8:30 p.m. IST. Okay, every week. And just go to the courses, and here you will see all the lecture. Okay, because currently we are live, so that's why it has started the live directly. But once live is over, you will able to see the lecture as well as the resources. Okay, everything you will be able to see that here. So with Udon Plus I can access GNAI course also, everything. Okay, treat everything you can access, whatever course we have on the Uran portal, everything you can access. Okay, not only course, you can also access books, webinar. Okay, then Uran assistant, everything you can access. Fine. Yeah, and if you have missed out, guys, my previous actually lecture on the computer vision, so please check out our day two lecture. Sorry, day one lecture, because there I was discussing about introductory part. I was talking about the images and all, right? So I think you already got it. What is the today's topic? So today we'll try to discuss about like convolutional neural network like CNN, and we'll try to understand the image data and the filters, okay, and its use cases, okay, how we can use the filters to extract the features from the image. So this thing we'll try to discuss. First of all, I will discuss some theoretical concept, okay, then I will also show you the practical of that, okay, so that your understanding will be more clear. So let me know, guys, if you're ready. Can I start with the session? So please give me a like, any kinds of emoji in the chat so that I can continue. Are you ready, guys? Can I start? So please try to interact with me. Otherwise, I will feel like I'm recording the session. Okay. Okay, great. Fine. Hmm. All right. So let's start. So what I will do, just a minute. I will open up my board. Okay. Hmm. So see, guys, we are starting with computer vision. Okay. So I think I already given you the idea about computer vision, what exactly the computer vision is. That means it gives the computer or machine the ability, okay, to the vision system like a human. Okay. But to perform this particular, let's say, vision task, it has to use one neural network. We call it as a convolutional neural network. See, we have three kinds of neural network. So maybe you have already learned, right? Uh, those who are familiar with deep learning, so maybe you have learned about ANN. Yes or no, guys? What is the full form of ANN? Artificial neural network. Neural network. Are you familiar with ANN, guys? Anyone here? So that's why I told you deep learning knowledge is required. Okay. Hmm. Then we have something called convolutional neural network, called CNN. Convolutional neural network. Okay. This is called CNN. So this thing we'll try to learn, okay, through the entire course. Then we have another neural network called RNN. Okay. The full form is recurrent neural network. Okay. So we use RNN in the NLP task. So whenever, let's say, you are having text data, not textual data, time series data, that time you can start with recurrent neural network. Okay. And whenever, let's say, you are learning deep learning, you are, let's say, learning about the neural networks, okay, back propagation, that means the fundamentals of artificial neural network. That time you have to understand the ANN, and this is the foundation, guys. So if you don't know about the ANN, it would be difficult for you to understand the CNN as well as the RNN. Okay. So yeah, so I can say actually this is the ABCD of actually neural network or deep learning. So it is like very much required. So we don't have any application with respect to the ANN. Okay, if you ask me, sir, what kinds of application I can create with respect to the ANN, you can create ANN architecture. You can also use tabular data to solve some problem statement, but I won't suggest that because most of the tasks can be solved with the help of machine learning model. Okay, if you're having tabular data, but sometimes whenever you are having complex data, that time you can use ANN. Okay, but your actual task could be started from the CNN. Okay, because CNN we use in the computer vision industry, computer vision domain. Okay, and inside computer vision, I already told you, we have different tasks, like we have image classification, object detection, image segmentation, key point detection, OCR, right? Then object tracking and so on. So if you want to perform these are the operation, okay, if you want to play with the image data, video data, that time you have to use this convolutional neural network architecture. Okay, and this is what your computer vision. And those who are interested in NLP, like text generative AI, okay, so they can learn the RNN, that means recurrent neural network, and this is the foundation of generative AI. Okay, that time. So best framework is TensorFlow or PyTorch in the current scenario for ANN and CNN. Both framework are good. Okay, if you ask me which we have to choose, I'll say try to get the idea on top of both framework, because See, there are different companies actually, they prefer actually different framework. Let's say some of the company will prefer to use TensorFlow, some of the company will prefer to use PyTorch, okay, but at the end the functionalities are same, okay, but the syntax is different only, right? But PyTorch is mostly used in the research field, okay, it is mostly used in the research field. And I saw like whenever it comes to the development, let's say people prefer the TensorFlow because it has the Keras API. So as a high level you can write everything there, but PyTorch is a little bit low level, okay. You should have good knowledge on OP programming, then will be able to write the code on top of the PyTorch, okay, otherwise it would be a little bit difficult for you. So that's why if you want to do the research level work, if you want to let's say do let's say very minor level work, that time you can use the PyTorch, okay. But if you want to create a application quickly, okay, you don't know let's say you are not worried about like very let's say a detailed implementation and all, that time you can go with the Keras one, TensorFlow one, because it has the high level API, right? That's why. But I will suggest try to get the idea on top of both framework. It will help you a lot. Okay. Hmm. Fine. So now let's try to understand what is convolutional neural network exactly. Okay, so here I already kept one definition and I already kept one image. So here I believe that some of the people are already familiar with this CNN. Okay, maybe they have already learned, but if you are not familiar with, you can see here. So convolutional neural networks, also known as connet or CNNs, are the special kinds of neural network for processing data that has a known grid-like topology. Okay, like time series data 1D or images 2D. Okay, so here you can see you have to know this grid line topology. Okay, grid line topology data. Now, can anybody tell me any data name which is having grid line topology? Anyone? Let me know. I think yesterday I was discussing about, right? I already showed you grid line topology. Give me one example of that. So yeah, I think you already know that, right? Image is like having grid line topology. No, amnesty is a data set name, but at the end, if you see what is image exactly, let's say any kinds of image. Let's say this is one image. So if you see this image in detail, what it is exactly? It's a pixel, right? And then it's a pixel. Sorry. And then it's a pixel. And here can you see it is having grid line topology. These are the grid actually. These are the grid, okay? These are the grid. And there is another kinds of data called time series also having grid line topology. Let's say this is t1, then this is t2, okay, then this is t3, like that. So this is also call it as actually um, grid line topology data. But we are not going to use the time series here. Mostly we'll be working with the images, okay, images and videos. And what is videos? Videos is nothing but it's images only, but it's a frame, let's say multiple images, okay, frame per images. Hmm. Collection of images, we call it as a video. Okay, that's why convolutional neural network we have to use, okay, this particular convnet we have to use on the grid line topology kinds of data, and which is known as image data, okay, because it will work on top of the image data. Why it will work on top of the image data? Now you can ask me, sir, can I also solve let's say image problem statement will help with the help of ANN? Is it possible? If you ask me, I'll tell yes, it is possible, but there is a problem actually. Okay, I'll let you know, okay, why there is a problem. So here you can see I kept CNN architecture. Okay, this is called CNN architecture. You can see convolutional neural network architecture. So in this architecture, you can see here you have one input image. Okay, here I think you can see this is a zebra, and this is the CNN architecture. You can see this part is called CNN architecture, CNN layer, conv layer. Okay, we call it as a conv layer, conv layer. So inside you can see conv layer we have convolutional. Okay, then we have something called pooling. Okay, convolution and pooling, we'll try to discuss what is convolution and pooling in detail. No need to worry as of now, just try to understand. In CNN we have convolutional layer, okay, and pooling layer. So wherever you see this particular conv layer and pooling layer, you have to understand this is a CNN architecture, okay. And this part I think most of the people are already familiar with this part of the architecture. Let me know. So what we call this part, this part we call CNN, this part we call CNN, and this part, are you familiar guys? Those who are from deep learning, I think you know that. what we call this part? So please reply quickly. Flat and N. Yeah, so it is actually dense layer, or you can talk about actually your ANN, artificial neural network. Yes or no? Because at the end you can see it's a fully connected neural network. See here, you have different neurons. It is interconnected. Okay, so it is fully connected. FC. Okay, FC or ANN, right? So this part you already learned. This part you already learned. You know, okay, how ANN works. Okay, but the additional architecture, okay, in computer vision, you will see this convolutional layer, CNN layer, and inside that you have convolutional and pooling. Okay, and you also use something called ReLU activation function. Okay, because with conv layer, ReLU activation function works better. That's why researchers use ReLU activation function in most of the architecture. You will see that. Okay, apart from ReLU, you have different like activation function like LU is there, then sigmoid is there, right? Different activation functions are available, but ReLU works better. Okay, why ReLU works better? I think you already know if you know about ANN. Okay, inside ANN you already learned why ReLU works better. Fine. Hmm. So you can see uh, if you combine all the architecture together, okay, this is called actually convolutional neural network. Okay, so whenever you are giving one input image, first of all it will try to extract the feature from the image. Okay, how it will extract the feature from the image, I will let you know. So it use something called kernel. Okay, kernel or filters. Okay, with respect to the filters, it will try to extract the features from the image. Okay, and this particular features it will send to the, okay, artificial neural network, an artificial neural network will try to understand, okay, what kinds of image it is, and it will give you the output. Okay, whether it's a horse, whether it's a zebra, whether it's a dogs. Okay, like that. Okay, so the main part of the CNN, okay, CNN is to extract the features from the image. What kinds of feature, I will also let you know. How it will extract, I will also let you know. Okay, we call it as a filters. We use something called filters. With respect to the filters, we'll try to extract the features from that. Okay. Hmm. So let me know, guys, did you get it as a high level? What is CNN exactly? Let me know. Clear? If you have any doubt, you can let me know, guys. Please let me know. Otherwise, I'm not going to repeat again. If you have any doubt, please let me know right now. Otherwise, write clear in the chat, all of you. Clear, all of you? Let me also see the chat here. So yes, 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 fully connected layer. Okay. So I think it is clear now, right? Hmm. Fine then. So let me just. Hmm. Okay. So I'll open up my board again. Hmm. Okay. So what do we learn, guys, in CNN? What we have in CNN architecture? The first thing we have, which is called convolution. Okay, convolution. Then we have pooling. Okay, pooling layer. Then we have FC layer. Okay, that means fully connected layer. Okay, if you combine them all together, this is called CNN. Okay, convolutional neural network. Got it? And how this convolutional neural network came? Okay, how? I mean, from where actually it got inspired? Okay, anyone know that? So it is inspired by visual cortex. Okay, visual cortex, visual cortex of human brain. So if you search about visual cortex on Google, let me show you. So visual cortex. So here is the part of visual cortex. I think there is an image. I think this image, primary visual cortex. So see, there are different images actually. If you open it up, so those who are from biological background, I think they already know, right? They can compare. Let me open this image in a new tab. See, I think this image is visible to all of you. So see, in actually human brain, there are different section. Okay, So one of the section is called visual association area, and which is called actually visual cortex. Okay, so this part of the brain can help you to visualize something, okay, to recognize something exactly. So it is connected with your eye directly. Okay, so researcher also got inspired from this visual cortex. Okay, and they introduced something called CNN, convolutional neural network. Okay, so this is the similar kinds of, okay, architecture they have developed, okay, in a brain. I hope it is clear now, right? Hmm. Yeah. So see, at the very first time, I think it's around 19, okay, 1998. There was a researcher. His name is Jan Likan. Okay, Jan Likan. Do you know his name, guys? Jan Likan. I think you know who is Jan Likan. Okay. So he used to work in the lab actually called um, 80 and T. I think. Okay, 80 and T. Maybe 80 and T, right? Just let me search. Jan Likan 80 and T lab. Yeah, so if you search over the Wikipedia, you can see that Jan Likan, AT&T lab, maybe he used to work. Bell Labs. Yeah. So in 1988, Lian Likan joined the Adaptive System Research Development at AT&T Bell Laboratories. Okay. You can see that. Okay, and for the first time, he introduced, okay, one CNN architecture, okay, and which will able to recognize actually bank check digit, okay, bank check digit recognition. Guys, do you know what is digit recognition? Are you familiar with amnist amnist data, guys? Anyone? Amnist, like handwritten digit, right? So you already use this data, amnist data, right? So this is also handwritten actually digit data. So for the first time, Ian Likan proposed one architecture called CNN architecture, and that architecture was they are using for the bank check digit recognition. Okay, for the very first time. Hmm. Then later on, actually, from the Microsoft, Microsoft, okay, they introduced something called OCR, optical character recognizer. Okay, and it can also recognize handwritten digit. Okay, any kinds of handwritten digit it can recognize. Okay, later on, whenever let's say this CNN got evolved, later on there are some application came like facial recognition. Okay, then you have self-driving car. Okay, and so on. These are the application came in the market later on. Okay, but for the very first time, Jan Likan actually proposed this particular architecture. Okay, for the handwritten digit recognition. Yeah. Yes, you were right. The data was actually, I think the image size was 28 cross 28 images. Okay. Hmm, hmm, right. Now let's try to understand why we are not going to use ANN for the image kinds of task. Okay. So for this, let me just take one image. Just a minute, guys. I'll take a image. Okay, and let me show you why we are not going to use um, this ANN. Okay. So this image actually I'll try to use. Hmm. So I hope you can see this image, guys, right? Visible, right? Okay. So here my topic is why not use ANN. Okay. So here I can write some point. Uh, the first point, we have to know, um, ANN why we can't use, because of high um, computation computation cost. Okay. Then the second problem, which is called overfitting. Okay, overfitting. And the third problem is of important, okay, information uh, of pixel. Okay, so these are the main point actually. Because of that, we can't use ANN. Okay, uh, for the image recognition or classification or any other task. Okay, we don't use image data with the ANN. Now, I think yesterday I was talking about the image, right? What is image exactly? I think I already showed you. Image is nothing but it's a pixel at the end. See, it is having a pixel value, and inside that we have actually different numbers. Yes or no, guys? Yesterday I was talking about it. Now, this is our image. Actually, this image is having a size. How to calculate the size? You can count the pixel value, 1, 2, 3, 4, 5, like that. You can count the image size. Let's consider this is a 40 cross 40. Okay, 40 pixel image. So height is 40, width is also 40, and inside that there is a monkey. Okay, inside that there is a monkey, and you can see this is a two-dimensional image, 2D image, because it is having two axes. So this is what called x-axis, and this is what we call it as a y-axis. Okay, so that's why we call it as a two-dimensional image. Fine. Now, if I want to, let's say, give this data to my model, let's say I want to use one artificial neural network. So what I can do, I can again take this image here. Hmm. Let's say here I have created one fully connected neural network. So let's create a fully connected neural network. So this is my fully connected neural network. Mm, mm. This is my fully connected neural network. So there is a connection. Okay. Hmm. Now, how we can pass this data to my fully connected neural network? Any idea, guys? How we can pass the data, this particular data? So you can see here, it is having a pixel value now. So this is the first row of the pixel. Okay, this is the first row of the pixel. Let me again show you. This is the first row of the pixel. So what we can do, we can take this row. Okay, we can take this row here, and we can extract all the metrics like that. Okay, we can extract all the metrics like that, all the number. Okay, so this is the first row. Then what I will do, I'll take the second row. So this is the second row. Again, I will take it, and I will extract all the value. Okay, I'll extract all the value. Then I will also do for the next one. Okay, let's say third one, fourth one, and like that, so on. Okay, then once we have extracted all the, okay, all the rows, what I will do, I'll send it to my neurons like that. Okay, I'll send it to the neurons, and based on the, okay, input size, you have to take the input layer. Okay, input neuron size. Okay, I think you know how to create the fully connected neural network, so I'm not going to explain in depth. So that's how actually you can create the architecture. Got it, guys? Hmm. Now see, if this image is 40 cross 40, 40 cross 40, can anybody tell me what would be the input size then? What would be the like first input size of the pixel? Any idea? If you just calculate 40 cross 40, what would be the number? I think it would be 1600, right? 1600. So you have to take 1600 input layer. Okay, that means the neurons at the very first layer. Okay, 1600. And now let's say at the second layer you have taken 500 units, okay, of the neurons. Now just try to calculate 1600 times 500. Okay, what would be the number? You can calculate. So I'll open up my calculator. So let's say 1600 times 500. Okay, now see, this is the size of the neuron. Okay, this is the size of the weights of your architecture. Okay, now tell me guys, is it possible, is it possible to train these are the weights in a low configuration machine? Tell me, is it possible? Let me know. It's possible if you are having high computational machine, it is possible. Okay, or if you are taking any cloud based system there, if you are training, it is possible. That's why at the very first time I showed you, you will be having the problem of high computation cost. Okay, that means yeah, your weight size is increasing, and if your weight size is increasing, definitely your computation cost is also increasing, right? So this is one problem. And again, if you see that the data actually you are giving to the ANN, okay, because of this weight size, okay, let's say at the very first layer you are having this amount of weights, okay, this amount of weights, and now just try to consider about the next layer, then next layer, okay, this next layer. Now if you calculate all the weights, okay, together, you will see that you will end up with a very big amount of, okay, weight size. And because of that your model will get overfit, because these are the data actually is very simple, these are the data is very simple to this particular model. Okay, see, I'm not talking about uh, feature wise it would be simple, but pixel wise it would be simple. Okay, pixel wise it would be simple. That means it can only work better on the training data, but whenever you are giving any kinds of test data, that time it will fail. Why? Because we know that if I search for, let's say, dogs, okay, dogs over the Google, so it's not like that you will see only one kinds of dogs, there are different kinds of dogs. You can see there are different kinds of dogs. Let's say you have trained one model with this particular dogs. Okay, so let's say I can take one dog image. Let's say you are taking this particular bulldogs. Okay, so you have taken this image, you have trained one model, but whenever you are giving these kinds of dogs, okay, these kinds of dog image, your model will fail that time, because your model has memorized these particular features, not these particular features. It is not generalized if you're using the ANN architecture that time. Okay, so that's why we will be having the problem of overfitting here. Okay, then loss of the important information of the pixel. Why? Because you can see that to identify this is a monkey, I also need to understand the position of the eye, okay, and position of the mouth, nose, and position of the mouse, yes or no. Let me know guys, because you can see eye is also black, okay, nose is also black, okay, sometimes mouth is also black, right? So if you are giving these kinds of features to the ANN won't be able to understand whether it's a eye, whether it's a nose, whether it's a mouth. Then how it will identify it's a monkey? Okay, so that means you are losing the information, important information about of the pixel if you're using the ANN here, because here you are using the flattened actually, let's say, layer. You are taking all the let's say pixel value, you are doing the flattening operation. Flattening means you are keeping in just only one line, okay, you are combining everything, then you are passing to the model. Okay, that's why you are losing the feature information here. Okay, yes. So because of that actually we are not going to use ANN for the image data or any kinds of video data. Okay, because it won't be working here. I hope now it is clear. Love you. Hmm. Now let's try to understand how CNN will solve this problem. Okay, how CNN will extract the features and how it will try to understand. For this I'm going to take another image. Just a minute, let me take some image. Hmm. So here what I can do, I can take some image. Yeah, so let's say this is a handwritten digit image. Okay, I have taken. Now in this image actually you can see 9 has been written, okay, in a different form. So that's how you can also write 9, that's how you can also write 9, that's how people will write the 9. Okay, because it's a hand digit, a handwritten digit. So it's not like that everyone is having the same handwriting. So some of the people will follow this approach, some of the people will follow this approach, and some of the people will follow this approach. Okay, but as a human you can understand this is a 9, but what about the machine? Okay, how machine will try to understand it's a feature? Okay, yeah. So see what happens in the convolutional neural networks. Okay, so let me give you one example. Let's say Mm, here I'll take this color. Hmm. See, in the conv layer, what happens exactly? Let's say this is a conv layer. This is a conv layer. Okay. So inside conv layer, it will do the feature extraction. Let's say I want to extract the feature of this particular image. Let's say this image I'm considering as of now. Let's say this is 9. Okay. And I want to, or let's say I can consider this image. This image, I think it would be good. As of now, let's consider this image. Okay. So this image, I want to extract the features. So this image I'll pass to the conv layer. So inside conv layer, what will happen? So it will extract first of all edges. Okay. So let me draw. I can draw like that. Mm, okay. Hmm. So first of all, it will extract the edges. Now, what exactly the edges is, guys? Do you know what is edges exactly? Edges. Let's say I want to see the edges of 9. So what do you think about the edges? Any idea? See, edges is nothing but it's some vertical and horizontal line. So you can see some vertical line. Okay, you can see some vertical line, again some horizontal line. Okay, again some horizontal line. Okay, now if you combine them, if you combine these kinds of vertical line, let's say you have this kinds of line, you have this kinds of line, this kinds of line. Okay, then you have this kinds of line, then you have this kinds of line. Okay, now if you combine them together, okay, if you combine them together, okay, you can consist a 9 form. Okay, let's say I already told you it is having different edges. Now if you combine all the edges, it will look like a 9. Okay, it will look like a 9, and this is called actually edges. Now in the conv layer, okay, in the conv layer, convolutional layer, at the very first layer, what it will do, it will try to extract the edges from the image. What kinds of edges? I will also, I already told you, it will extract some vertical line, horizontal line, like that. Let's say it has extracted this particular edges and this particular edges. Okay, then this particular edges, let's say these edges. Okay, or these edges. Okay, so these are some edges, we call it as a edges. Edges, edges. Okay, we call it as a edges. Got it? You can also call it as a shape. Different shape it will try to extract of that image. Yes, guys, let me know. Any kinds of image, guys. If you consider any kinds of image as a human, how we understand the image? Because at the very first time, my I will see the edges of that image. Any kinds of, let's say I'm talking about this dog. How we identify the dog? Here you can see also we have the edges. Now I'll copy this image, and here if I paste it, see here also we have edges. See, so that's how we have edges. Okay, we have edges. Eye is also having some edges. Okay, nose is also having some edges. Okay, some vertical line, horizontal line, vertical line, horizontal line, like that. Okay, and if you combine all the edges together, okay, it will build a complete image. Okay, and if you add some color, that means your image would be fulfilled. Okay, makes sense, guys? Let me know. Are you getting what I'm trying to say exactly? Let me know. Please reply me. Yes, all of you. Great. Okay. Yeah. Now, it's not like that you will be only using one convolutional layer. Okay. You have to use multiple convolutional layer. Now, let's say you are using another convolutional layer. This is another column layer. Okay. So in this column layer, what will happen? It will extract some more complex feature. It will extract some more complex feature. Okay. Like let's say these kinds of feature. So some round feature. Okay. This kinds of, this kinds of, this kinds of this kinds of. Now if you see these edges and these edges, this edges is capturing more sorry, this convolutional layer is capturing more complex, let's say, edges, because these edges is you can see simple, very smaller edges, but as compared to these edges is a little bit bigger. Okay, now if I combine, okay, if I combine, these are the, let's say, I mean, these are the, let's say, symbol. Let's say how I can combine. Let's say I will first of all take this symbol. Okay, then I will take this symbol. Okay, then I will take this symbol. Then I will take this symbol. Now can you see it has become a 9 digit like that? Yes or no? Are you getting, guys, how it is trying to extract different edges, small edges, and with the help of this combination of the edges, how it will try to understand the complete image. Okay, this is what actually feature extraction from the image. Okay, and to extract this kinds of feature, we will be using conv layer. Okay, and inside conv layer we use something called filters. Okay, filters. With the help of filters, actually we'll try to extract these kinds of edges. So there are different filters are available, like we have Sobal filters. Okay, Sobal is one of the filters. So with the help of Sobal filters, you can extract a vertical line. Okay, vertical line. Okay, and horizontal line. I'll give you one example, practical example. I'll show you. Okay, I'll show you how it will extract the vertical line and horizontal line. Sobal filter. Okay, that's how we have different filters. And in cnn everything is neural network. Okay, this filter will automatically generated. Okay, this filter weight would be automatically generated, and during back propagation, okay, this weight will adjust. Okay, and every epoch whenever you are training the model, it will try to adjust the filter weights only, so that this particular filter can efficiently extract the edges from the image. Okay, this is the complete idea of CNN conv layer. Okay, and inside that, that's how it does the feature extraction. Clear, all of you? Okay, we call it as a feature extraction. Feature extraction. Extraction. Okay, feature extraction. Okay, let's say there is a cat. Let's say I can draw, but let me type. Let's say there is a cat. Okay, so let's say this is the cat. Now if I want to extract the feature of the cat, guys, so first of all, and the first conv layer, what it will do, let's say this is conv1. It will extract different edges, small edges like that. Okay, then conv2, let's say this is first, this is second. It will extract some complex feature like that. Okay, then third number layer, it will extract some, let's say, more complex feature like the face. Okay, like the tail. Okay, like the legs, like that. And if you combine all together, okay, if you combine them all together, so it will be a cat. It will be cat image. Okay, so that's how actually it works. Got it? Hmm. So far, if everything is clear, so I can move to the practical. Okay, I can show you how this filter can extract actually edges. That means this particular features. Okay, I'll let you know. We'll try to see one example of Sobal filter. Okay, clear, all of you? I think it is clear, all of you. Okay. Okay, now let's go to the practical part and let's try to understand the filters and and its use cases. Okay, we'll try to see the image example. So for this, I'm going to open up my collab notebook, all of you. You can also open up your collab notebook. I'll take a new notebook and here I will do everything. Going forward, I will also show you how to set up in your local machine and all. No need to worry. And guys, if you want to train let's say on your local computer, let's say you have a GPU but you don't know how to configure the GPU for the training, so you can follow this video. Let me share you one video. So this setup video actually I have recorded. GPU, this one. So how to set up NVIDIA GPU for the deep learning. Okay, deep learning, installing CUDA toolkit and CUDA CNN. So those who are interested using their local GPU, guys, you can follow this video. Okay, I'm sharing in the chat. So this is the video I'm also sharing in the dashboard. Okay, so this video will give you the entire idea how you can set up your GPU, okay, for the deep learning task. You can check this video, guys, all of you. Fine, so here I'll zoom this screen. Just a minute. Zoom the screen. First of all, let me give the name of the notebook. So I can give day 2 uh, image, or let's say filters, use case. Okay, so here I'll connect the notebook, and let me also share you the link, all of you. No, you should have NVIDIA GPU, okay, for the deep learning, frankly. Otherwise, it won't be working. If you want to work in the deep learning, you need NVIDIA GPU because it is having the CUDA, okay. So copy, and this is the notebook link, guys. I have shared in the chat. Let me also share to all of you. So whatever code I'm going to write, everything you will get here, okay. So here I have one image, guys. I downloaded from the internet. You can also download any kinds of image, it's up to you. So let me show you this image. So this is a car image, guys. I'm having one car image. You can see I have downloaded from the Google. You can also download. So this image I'll try to upload in my Google Colab. So let me upload. So here I'll upload this image. This is the image. Hmm. So first of all, uh, what I will do, I will try to define the image path. So image, or I can write like that, img underscore path, okay, is equal to, this is the image path. I will copy, and here I'll try to mention. Let's execute. Okay, now let's import some library. Okay, required library I need. So I need, these are the required library. So I need matplotlib, and inside matplotlib there is a function called mp image. Okay, so with the help of that you can load any kinds of image. Okay, matplotlib, with the help of matplotlib you can also load any kinds of image. It is also possible. Then numpy and cb2. Cb2 means OpenCV library. Okay, so let's say I want to load any image, I want to do some pre-processing, so I can use OpenCV for that. So let's import, these are the library. If you are using Google Colab, you don't need to set up. Otherwise, you have to install it with the help of pip package manager. Okay. So first of all, let's try to load the image with the help of matplotlib. Why matplotlib and CB2 I'm showing you, because of, there is a reason. Okay, because both is having different way to load the image. Okay. So first of all, let's try to see the matplotlib image loader. So to load the image with the help of this matplotlib, so you have to call this function mp image. Okay. Mp image dot imread dot im read. Okay, inside that you have to pass the image path, and this will give you the array. I can store in a variable called car1. Okay, and let me execute. Now if I show you this car1, it's a matrix, you can see. Okay, It's a matrix. So if I show you the data, see, it's a matrix, guys. So what is the size of the matrix? You can see it is having 168 pixel and 300 pixel comma 3. Now can anybody tell me why? So this is the height of the image, I think. Let me show you. If I show you the car na. Hmm. So this is the height of the image. This is the height of the image. This is the width of the image. Okay. And why it is 3, guys? Can anybody tell me why it is 3? Yesterday I told you why it is 3. Tell me why this. I mean, here you can see 3 because we understood height and width. And what is 3 then here? It's a channel, right? RGB, because this image is a color image and color is image is having 3 channel. Okay, that's why you can see 3. Okay, yeah. If you want to see the shape directly, you can see like that car1 dot shape. So it will give you the entire shape of the array, because at the end it's a numpy array, right? Hmm. How you will understand it's a numpy array? You can check the type of the array. Type car1, it's a nd array. Okay, numpy array. Now if I want to, let's say, convert this array to image, what I can do, I can use matplotlib, this plt, okay, dot I am show, okay, image show. What I want to show, this car1 matrix. Now it will convert it the image. See, okay, this is the original image. Got it, all of you? Now let me show you another experiment. Now let's try to load the image with the help of OpenCV. Okay, OpenCV package. So let's call cv2. Okay, cv2 dot imread. Okay, imread. Inside that I will pass my image underscore path, image path, and it will give you the array again. So let's store in a variable. I'll store in a variable called car1, and we are using cv2. So let's write cv2 here, cv2. Okay, car1 cv2. Now if I execute, so this will give you one matrix. See, again the same matrix you are getting. So this is the height, this is the width, and this is the channel. Okay, and how to convert this matrix to image again? For this you can use this package, Google Colab patches. Okay, cv2 image show. So this is the package you can use. So now let's show the image. Inside that I'm going to give the matrix name. Sorry, so let me copy, and yeah, let me pass. See, again it has loaded the image. Okay. Hmm. Now one thing I want to show you, let's say if I do now plt.imshow. Now let's show this image with the help of matplotlib, and inside that I'm going to pass this car1, okay, cv2. Now one thing, just try to observe. See, now can anybody tell me why it happens like that? So the original image was like yellow color, but whenever I load it, okay, whenever let's say I used a matplotlib, okay, so this color has become blue. Why? Any idea? Any idea, guys? Because you always need to remember this line. Let me comment here. CB2 reads image as a BZR, okay, blue, green, red, and matplotlib reads the image as a RGB, okay, red, green, and blue. So that's why this color is changing. Okay, yeah, opposite color. Yes, Subham, you're right. RGB and BGR. Yes, Franklin, you're also right, right? But how to handle this kinds of scenario? Okay, how to handle this kinds of scenario if you are facing this issue? So definitely you can also fix it. So what you can do, you can use OpenCV only to fix that issue. So this is the code snippet. Let me show you. So the image you are getting, okay. So you are trying to convert the color, okay. How you are converting? You are converting to Bezier to RGB. Okay, you are converting to Bezier to RGB. You can see CVT to convert color. So you are giving the matrix, okay, of the image, and you are telling the color. I want to convert to Bezier to RGB. Okay, then again I am showing the image with the help of plt.imshow. Now if I execute, now see your image would be in a original form right now. Okay, I hope you got it. Now not only like color gradient, I can also convert this image to the uh, this one grayscale image, that means the black and white. It is also possible. How? Only you just need to change this particular parameter. So color, okay, bgr to gray, okay, bgr to gray, and you have to give the cmap. Cmap is equal to gray. Now see, if I again execute, now your image would be in a gray format, you can see. Okay. Hmm. So these are some like basics OpenCV actually operation. Okay, if you know about little bit of OpenCV, you can do this kinds of image manipulation. So Pillow, what reads in image? I think Pillow also reads in Bezier, Bezier or RGB. I'm not sure. You can search over the Google. Okay, because mostly I used OpenCV, not Pillow. Okay, I'm sure about the OpenCV, but not the Pillow. Hmm. Now, if you want to see like whether it's a grayscale image or not, and we know that grayscale is having only one channel. So for this, we can also show that. So I'll copy the name and let me show you the shape. Now see, only height and width, there is no channel. Okay, height and width, there is no channel because we have converted to the black and white. Okay, and I already told you, image is having every channel is having value from 0 to 255. How you can get? So you can get with respect to this parameter. So your matrix, and you have to take the minimum value first of all. So this is the minimum value 0, and if you see the maximum value dot max, it should be 255. Okay, in between you have all the number, see, 0 to 255. Why you do you prefer OpenCV to pill? See, from the very beginning I learned OpenCV. Okay, so that's why I'm more comfortable with OpenCV, so that's why. But both are good at the end. It's a choice of yours. Okay, both can be used, no issue. Personally, I, let's say, prefer OpenCV. You may prefer Pillow. Okay, you can use them. But I can say OpenCV is having more functionality than Pillow. Okay. So those who are working with the edge devices like Arduino, then Google Coral, okay, NVIDIA Jetson Nano. So with the help of OpenCV also you can let's say deploy. You can create lots of computer vision model and you can run on the edge devices because it's like more lightweight. Because it is also having some hard cascade model. So I uh, created a robot actually whenever I was in my college days with the help of this OpenCV. Let me show you. If you go to my playlist now in my YouTube channel, so there you will get one playlist called My Project. Let me show you. So here my project is there. So here I have created one robot. See, this is the robots. Okay. So the vision system you can see I created with the help of OpenCV. This one. So that time I was not like very much familiar with the computer vision. Okay, so I used OpenCV library to implement this entire system. Okay, you can check it out, and it is running on a edge devices. Fine. So let's go a little bit fast because we have to cover a lot. So now what we'll do, guys, we'll first of all understand the composition colored composition like image colored. Okay, because I told you now every uh, like color is having color image is having three channel RGB, that means red, green and blue. So let's try to see in a visual representation. So here I will just comment understanding composition of the colored image. Okay, so for this I created a function. Okay, I created a function. This is the function. This function, it takes a image array. Okay, it takes an image array, and what it does, it try to extract the R, G and B channel. Okay, and it will try to show with the help of this matplotlib. Okay, simple function. It will take an image array, that means color image array. It will try to extract RGB. Okay, it will try to separate RGB channel, and it will show with respect to the matplotlib. Okay, so let me execute this function. Now in this function I will pass my this image car CV2. So I think remember we loaded our image, this one. Okay, car 1 CV2. This is the image array. Okay, this is the image array, you can see. Okay, so let's pass this image and try to extract the three channel. Okay, so what I will do, I will call this function, and inside that I'm going to pass this image array. There's a parameter image array I need to pass. Image array equal to, this is the image array. Okay, now see, if I execute, it will extract three channel and it will show you. See, this is the image, guys. Let me zoom out. I think it is visible now. Can you see? So this is my original image. Okay, this is my original image. So why it is showing this color? Because of that BGR and RGB. You can again convert it to the original color. Okay, but see, this is the main thing. This is your original image, and after applying to this function, it has extracted three channels. So this is the red channel, this is the green channel, and this is the blue channel. Okay, and if you combine them together, okay, it will become your original image. Got it? So whatever theory we learned, I think now you can relate with the practical. Yes or no? Okay, we learned like color image is having three channel RGB. Now we can see the visual representation of that. Fine. Hmm. Okay. Now see, instead of using this car image, what I will do, I will create my own image. Let's generate some random number. So let's say I'm generating some random number with the help of NumPy package. Okay. Now the number pixel value I'm generating, it's 0 to 255, because what I told you, uh, every pixel value is having the number 0 to 255, and the image size I want to generate 6 cross 6 by 3, that means like that. So height would be 6, width would be 6, and channel would be, okay, 3. Okay, channel would be 3. That means the depth of the image, it is having 3 channel, 1 2 1 2 and 3. Okay, 3 channel. Okay, so let's try to create this particular matrix. So this is the matrix, guys, I created. It's just a random matrix. Okay, I created. You can see this is the random matrix. Now let's pass this matrix to my function. Random colored image. I'll pass it here. Now see, this is the original image I generated with the help of NumPy package. And after extracting the color, this is the red channel, this is the green channel, and this is the blue channel. Okay, I hope you clear now. Fine. Okay, so we saw actually different things. Now let's try to understand the filters, because I told you with the help of filters, your CNN extract the features from the image. Okay, so it will extract the edges, different edges. Now let's try to see how it will extract the edges. So for this, I'm going to use a filter, and the filter name is Sobal filter. So this is the Sobal filter matrix representation. So you can search over the Google Sobal filters. Sobal filters. You can see the matrix of Sobal filters. I think somewhere. See, this is the Sobal filters. Okay, plus one, plus two. So let me show you. See, plus two, plus one, then 0, 0, 0, minus one, minus two, minus one, minus one, minus two, minus one. Okay. Now, if you do that transpose of it, this is the transpose one. That means this will extract the vertical edges, and this will extract the horizontal edges. Okay. So the same actually filters, you can do the transpose operation like that. So here you just need to do transpose operations. What I can do, instead of writing like that, I can do sobal.t. Okay, t means it will do the transpose operation because it's a numpy array. Okay, now if I print it, now see, this is the transpose of it. Okay, sobal is not defined because I have to execute this code. Now let's execute. Okay, now see, this is the transpose matrix. And how transpose happens, guys? Do you know how transpose happens in the matrix? Any idea? I think you already know, right? Transpose, how transpose happens. So let's say this is my original Sobal filter. Okay, if I do the transpose operation, what will happen? First of all, it will take, okay, tell me. So like that, 1 to 1, 1 to 1, then it will take 0, 0, 0, 0, 0, 0, and uh, minus 1, minus 2, minus 1, minus 1, minus 2, minus 1. Okay, in a horizontal form. This is called transpose. Yeah, by swiping the rows and column, frankly. Yes, you're right. Okay, that means this both are by Sobal filters. Okay, these both are my Sobal filters. But the first Sobal filters, you can see this is the vertical edges. It will highlight the vertical edges. Okay, it will extract the vertical edges. You can see wherever this zero is aligned. Okay, you can consider like that. This zero is aligned in a vertical form. That's why this is called actually vertical edges detector, and this zero is aligned with the horizontally. Okay, that's why it is a horizontal edges extractor. Got it? How you will identify whether these filters will identify the horizontal edge or vertical edge. You can see the zeros alignment. Now you can see this is the vertical one, this is the horizontal one. That's how. Okay. Hmm. So now what I will do, I will create a matrix. Okay, first of all, let's create a matrix. First of all, let's generate an image, and I will show you how it will extract the horizontal edges and vertical edges. Okay, so let's say this is a matrix I will generate. This is a random matrix, guys. You can see 0 to 255 value. Okay, this is, let's consider this is the image. Okay, I'm generating. Now you can see this is the matrix. Sorry, image matrix. I converted it to the numpy array. Now see, this is the numpy array. Okay, now what I will do, I will show with the help of this matplotlib. This matrix I created, I will try to show in a grayscale image. Now see, this is what we have created. So this metric representation looks like that in a visual form. Okay, so this is the image. Now can you see here, you have the horizontal line as well, you have the vertical line as well. This is the vertical line, you have the horizontal line. I think you can see, guys, right? Hmm. Vertical line and a horizontal line. Okay, now let's do the convolutional operation. Okay, conv operation. So how this conv will work? So see, I can show you one image. By seeing the image, you can understand. Mm, what I can do. I have one actually visual representation. Just let me find it. Just a minute, guys. Let me find that content. So here I have some visualization. Okay, so here it is telling. So this is what your convolution. See, that's how convolution happens, guys. Okay, you can see this is the filters and this is your image. So it is trying to, okay, it is trying to see, it is trying to calculate the matrix. So this matrix is calculating with this image matrix, you can see like that. Okay, see, let's say this is your filters and this is your image matrix, and now it is trying to multiply, okay, every time, and it is creating a new matrix for you. Okay, that's how convolution happens. Okay, you can see this is the visual representation. So let's say this is your entire image, 28 cross 28. Okay, and this is your filters. It will try to calculate with respect to all the pixel. Okay, see, so I'll also share this notes with you in the chat so that you can see the visual representation of uh, filters. Let me also share it here. Okay, see, this is the actual filter works. So it is first of all multiplying with all the pixel. It is generating a new image for you. Okay, new output image for you. Then it is doing the aggregation, and this is the final image. Okay, and see, this is the visual representation in a matrix form, how things are working. So take time and open it up and try to see this visual representation. You will be able to understand, okay, how things are working. But as of now, I will not suggest go in depth, okay, in mathematical representation how things are working. As of now, just try to consider, okay, what is happening. The filter we created now, this filter, this Sobal filter we created, this Sobal filter will try to, okay, multiply with this pixel value, okay, just to extract the features, because I told you this Sobal filter will extract the vertical edges and horizontal edges. Okay, now it will identify, because this is the image pixel, right? You can see this is the image, and it is having the vertical line and horizontal line. Now Sobal filter will try to identify which one is the vertical line, which one is the horizontal line. But how? Because we have to multiply this matrix with this matrix. Okay, so I think you know how to do the matrix multiplication, guys. Yes or no? Matrix dot product, cross product, right? Maybe you have learned in your college days already how to calculate, how to, let's say, do the multiplication of a matrix, two matrix together, right? So I'm not going to explain this mathematics. Okay, I think I'm expecting you already know how to do the matrix multiplication and all. You already know that. Okay, that means we have to multiply this matrix with this matrix, image matrix, and it will extract the vertical edge and the horizontal edge. Okay, this is the idea. For this, we have to write a Python code. So this is the function I have created. So this function will do that job. So this is called simple convolution. So it will take the image filter, that means the Sobal filter, and the picture. Okay, the picture you want to apply. Then what it will do, it will try to apply this operation, the visual operation, you can see now. So every time it will move like that. So it will start from here, then next actually a row, then next row, then next row, then next row, then again it will go to the next column, next row, next row, next row, and like that. Okay, so all the pixel, it will try to do the multiplication, and it will create a completely new representation of the features for you. Okay, and it will do the aggregation operation. So this visual operation, okay, we are performing in this particular code. That's it. Okay, now let me execute. Hmm. Fine. Now let's try to see how things will work. Okay, first of all, mm, hmm. So what I will do, I will call this function. So inside that, I will pass my filter first of all, because it takes the filter, right? Which filter I will pass? I will pass the Sobal filter. Sobal. Okay, and which one? Sobal means the vertical one. See, I'm not passing the transpose one. Okay, horizontal one. I'm passing the vertical one. Okay, this Sobal, I'm passing it here. Okay, then I have to give the image as well, the picture. Which picture I will give? I'll give this picture. the picture I have created, example 1. Okay, now if I execute, but before that I will store this result in the result variable. Okay, because see, if you do the feature extraction, now if you multiply, it will give you a result. This is the result. This result I'm storing in the variable. Okay, this result variable. Now let me execute. Okay, so it is giving one error, image filter. Okay, it should be image filter, sorry guys, my mistake. Now this is the output you got. Okay, this is the output you got. Okay, and now let's visualize this output. How to visualize? I think we can use matplotlib to visualize. See, this result I'm passing it to the matplotlib and convert to the grayscale. Now if I show you, okay, result is not defined, it should be results. Now see, okay, and if I show you the original image, this is the original image. Okay, original image. Now guys, tell me, what is the difference you can see here? Tell me which filter I applied, guys. Which filter I applied, horizontal or vertical? Tell me, which filter I applied here, horizontal or vertical one? Sobal horizontal or Sobal vertical? Tell me. Tell me quickly. Sobal horizontal or Sobal vertical? Vertical one, right? Yeah. Now can you see it is only understanding the vertical line. You can see the vertical line is good here. We can see the vertical line. Rest of the horizontal line it has removed. Can you see? It is white. Okay, because it is not understanding the horizontal one. It can understand only the vertical line. Okay, because Sobal vertical can only understand the vertical line, not the horizontal line. That's why this is the original image you can see. Okay, now after applying the Sobal filter, Sobal vertical, you can see it is only getting the vertical line and rest of the edges it is trying to do the white. That means it's not extracting this feature. Getting my point? What I'm trying to say? Tell me, guys. Okay. Now let's apply. Now let's apply the horizontal one. Okay, because we applied the vertical one. Now I will apply the horizontal one. So let's apply. So to apply the horizontal, only you just need to do the transpose operation. So here Sobal dot t, that means transpose you are doing and you are giving the same example. And what I can do, I can execute it. And now let me show the results. Okay, now I'll also show you the original image. This is the original image. Original image. Okay, now see. Can you see? Can you see it is only considering the horizontal one now? Horizontal one and vertical one it is not considering. Getting my point? How feature extraction is happening? Okay, how with the help of filters, okay, you are extracting the horizontal edges and vertical edges. Okay, this is the visual representation and this thing is happen in the conv layer, guys, all of you. So whatever image you saw, dog, cat, anything, okay, dog, cat, anything, it will do the same thing. But the feature so filters will be using not the Sobal filters. Okay, we'll be using some more powerful filters. Okay, some more powerful filters. That particular filters will try to identify the complex pattern of the image, complex edges of the image. Okay, and this is what your convolutional neural network works. And these particular filters we try to identify during the propagation. Okay, during back propagation this weight would be adjusted and it will try to extract the powerful features from the image. Okay, and it will identify the image, okay, whether it's a dog, whether it's a cat, or any kinds of thing. Fine, let me know. Now let's apply this demo with our this one, this card image. Okay, so I will apply on top of my car image. So I think you remember, guys, I have one car image. Gray car image. I think you remember. We have one gray car image. Let me take that. This one, I think. So this is my gray car image. So let's use this gray car image and apply the Sobal vertical one. So you can see I'm using the Sobal vertical one and I'm giving the same car image here. Okay, gray car image. Now if I show you the results, now see, it will only extract the vertical line. Can you see? These are the vertical line only. See, vertical line, not the horizontal line. See, only the vertical line you can see. Now if I do the Sobal horizontal, that means the transpose, you will see the horizontal line. See, now it is more focusing on the horizontal line. Okay, horizontal line. See, this is the vertical one, this is the horizontal one. Now let me know, guys, is it clear, all of you? So Sobal operator is the same as the Sobal filter. See, the filter's name is Sobal. Okay, so the researcher has named it as Sobal, and they introduced this Sobal for the horizontal and vertical edges extraction. But in CNN, we use some more powerful filters. Okay, how it creates with the this back propagation technique. So let me know, guys, is it clear, all of you? How feature extraction happens? Let me know, all of you. So that's how your model actually understand whether what kinds of image it is. Okay. So color doesn't matter here, guys. Color doesn't matter. At the end, everything would be in a black and white. Only you just need to understand, your model needs to understand the edges, the pattern of the image. Okay. And that's how we understand the pattern. Yeah, same for the video. What is video? Video is just a frame of image, na? So first of all, you have to convert video to image, and the same thing you have to apply again. You have to convert image to video. Same thing, Franklin, right? So how was the session, guys? How was the session? How would you like to rate this session, guys? Let me know. This is the very like clear explanation I can give. Okay, on these filters and CNN. Thank you. Okay, 10 out of 10. Okay, good. Great. And I already shared the notebook, guys. You can practice. Okay, after the session, just try to execute all the cell all by, I mean, one by one. Okay, and definitely will be able to understand. And no need to worry. We have lots of things like we'll try to cover classification, detection. Okay, trust me, you will feel amazing, guys. Okay, once you learn all this, let's say, uh, technique, na. So you'll be loving working with computer vision. Personally, I prefer computer vision a lot. And all the resources would be available in your dashboard, guys. Again, I'm telling you, it would be available in your dashboard. So in the resources section, okay, resources section, all the resources would be available. See whatever resources I shared. And those who are watching from the YouTube, guys, if you haven't enrolled for this course, this computer vision course, okay, you can enroll from here. This is the computer vision course. You can enroll. Either you can take the Uran Plus subscription. Okay, great. So yes, this is all about today's session. We understand the convolutional neural network and the filters and its use cases. Okay, in the next class we'll try to see some more concept about the CNN. Okay, we'll try to see like filters in detail. Okay, and some more technique we'll try to see. We'll try to see the padding and stride, pooling layer, okay, different CNN architecture. So everything we'll try to see that. All right, just a minute. Okay. Any question anyone is having? Let me know. If you have any question, guys, you can let me know. Otherwise, we can end the session. Hi, Bappy. When is DL CVS starting? You can see here. Go to the Euron courses section. Okay, let me share my screen. Stop screen. Okay, so just a minute. Edit to the stage. Huh. So you can click here. Euron courses. Okay, you will see one sheet. So here you can see this DLCB project will start from 24 January. Okay, it will start. No, RNN we are not going to use in this class because RNN is for NLP, okay, not for computer vision. I need two more class, okay, to cover the basics of CNN. Then we'll start the projects, okay. Like we'll be learning different tasks like classification, object detection, okay, segmentation, tracking. These are the things. Can you put video on working on cloud platform like GCP, Azure, AWS? Definitely, I'll try to put. Okay. No need to worry. Okay. So yes, guys, this is all about today's session. I hope you liked it. Okay. So always remember consistency is the key here. I always tell. So try to practice as much as you can. And if you have any doubt, if you have any query, if you want to connect me, feel free to connect me on my social media. With that, guys, thank you so much. Bye, everyone. Good night. Bye. Thank you, all of you. Bye. And I will also share the handwritten notes. Okay, the notes actually I have used now. Let me also share these notes. Day two. CV. I'll share in the chat. It would be available in the dashboard chat, guys. Okay. Start it. Okay, it is already uploaded there. Fine. Any email live session? As of now, no, from my side. But we'll see that. So okay, guys. Thank you so much. Bye, everyone. Take care. Bye.